FADO is a company with more than 30 years of experience in tooling and injection molding. Our clients come mainly from automotive, electrical and lighting sectors, but we also realize projects for other industry branches such as consumer goods. Having both a tool shop and injection molding department under one roof makes it possible for us to offer complete molding solutions, from part design to production. We provide our clients with a vast range of services, including reverse engineering, simulation and optimization of injection process, as well as manufacture of prototype, pre-production and conventional molds. While building tools, we combine traditional, subtractive methods of production with additive manufacturing. For the last 4 years, we've been developing selective laser melting technology in the context of conformal cooling designs. Being able to use conformal cooling for our production purposes has been a huge asset, as it enabled us to learn the technology and understand its strengths and pitfalls. Cycle time is money. This is particularly visible in the case of high-volume production, where reducing cycle times by a fraction of a second translates into viable profits. In order to reduce the overall cycle time, we need to decrease the cooling phase, as it is the longest process in injection molding and can take up to 70% of the whole process. The time we need to cool a part equals the time required to absorb the temperature from the worst cooled insert area. Thanks to freedom of design offered by additive character of the technology, we're able to create optimal cooling that somewhat follows the shape of the cavity while maintaining a defined distance from the molding surface. This is especially useful in the case of long sliders or cores, where conventional drilled channels cannot guarantee efficient cooling. Providing uniform heat transfer from injected parts not only reduces the cycle time, but also minimizes warpages and part deformations that might appear due to uneven temperature distribution. On the other hand, implementing conformal cooling is financially justified mainly in the areas that are beyond reach for conventional methods of production, or in the case of high-volume production. It also takes some time to learn how to create channels optimized both in terms of cooling efficiency as well as insert maintenance and cleaning. We must remember that due to gradual scale agglomeration, thermal conductivity and cooling efficiency of channels will drop with time. That is why such inserts must be cleaned on a regular basis in order to prevent clogging or cooling efficiency loss.
One of conformal cooling application examples is a roller tube motor adapter, a part we produce for one of our clients. In this particular example, high ribs inside the part make it difficult to achieve uniform temperature distribution on the whole molding surface. Former solution was a spiral cooling insert coupled with a drilled cooling on the insert's bottom element. Such a solution was far from perfect, as a delta T for the upper and lower part of the insert was high above the acceptance range for semi-crystalline materials. Two conformal cooling designs were proposed. Although both guaranteed even temperature distribution, the second design generated lower pressure losses and was easier to clean. It is also a hybrid design. The bottom part was manufactured conventionally, and only the fragment which required cooling optimization was additively built on top. It enabled us to reduce build time and the cost of the insert. Optimizing the cooling design resulted in cycle time reduction from 90 to 36 seconds. In addition, we minimized the material waste from 9 to 0.15%.
Most of final part defects have their beginning on the early stage of product development and are usually related to insufficient verification of the design and technology concept. Preventive these actions after mold trials often means costly modification, necessity to accept some of part defects, or in some extreme cases, change of the mold design. Thanks to Moldflow simulation software, we are able to foresee potential problems related to difficult part geometries and counteract them at the early stage of design. In the case of cooling optimization, Moldflow coupled with our thermovision test bench is an important tool for cooling design and verification. Values obtained during simulation serve as reference point for the thermal behavior of the insert built in DMLS technology. Due to numerous factors influencing the insert quality, such as wall roughness inside cooling channel, simulation results obtained from Moldflow must be always compared with actual thermal behavior of the insert, flow rates and pressure losses for individual cooling channel. Only then we can be sure that our cooling design meet our expectations.
you.